Hello, my name is Daniel Collan of Asset 55. This short video is going to look at an advancement of an AWP opportunity, linking the traditional AWP process with completions enablement methodology. So at a high-level overview, this graphic represents what advanced work packaging is. In the front-end definition, there's the strategy and execution plan. We move into detailed design where we develop our CWPs, CWAs, and align our engineering and procurement work packages so that we can get into the creation of installation work packages during the execute phase. What this does well is it aligns the delivery of procurement and construction, and it can definitely improve bulk construction productivity through to about 65% complete. But it doesn't effectively enable the completions phase, which is often where schedule erosion occurs. We don't know up front what CWPs contain subsystem priorities. We don't know how many subsystems are contained within each CWA or CWP, and we don't know what the subsystem relationship is across our construction work packages. And finally, it doesn't automate the completions opportunities process to the work phase planner, which largely means this is a heavily manual process. So what we want to do is really start with the end in mind and bring this thinking around completions enablement much earlier. So starting with the end in mind is understanding startup sequence, commissioning sequence, the path of construction, bringing this all the way back into engineering. When we do that, we can optimize this path of construction, inclusive of the completions enablement methodology and thinking, which is going to enable smooth transition through commissioning and startup. Two of the key areas that are failing in the AWP process is the understanding of commissioning sequence. Whilst we end up conceptualizing this on plot plans, we need the attribute data to do this effectively. So systemization process, test pack development, cable routing needs to happen much earlier. First, we recognize the blockers. That systemization typically is a manual process. It can take somewhere in the order of 12 to 18 months on a large project, and it isn't complete until the project is about 30% into construction. That means the path of construction is already set. Test pack development is driven by the construction contractor, which needs subsystemized information, and cable routing happens too late. And a key element here is the population of the completions management system. What this then enables is to have access to the attribute data to optimize the path of completions. So some ideas in this space is to digitize the systemization process through a model-driven workflow, using rule-based approach, potentially linked through smart P&ID. From a test pack development perspective, this is easy to do a digital workflow through a 3D model, where at least from a planning perspective, test packs can be created in as little as 6 weeks. What this will support is the automated population of the completions management system, exporting data from the 3D model. The outcomes of this means the end in mind is available for the path of construction, completions and commissioning sequence is built in, it will improve your resource planning, and it provides a proactive and not a reactive approach to completions. If we think about completions enablement, we'll look at why it's important. So typically around 65% is a change in focus from bulk construction to the completions process. Statistics show that the last 25% takes up to 50% of the overall duration, and the last 10% can take up to 25% of the overall duration. This is all schedule erosion and significant cost and startup impact. When we understand in bulk construction, largely we're front-end loaded on progress weightings, structural steel is easy and largely complete, bulk fabrication of spools and install is relatively easy, and most construction contractors and fab yards are good at bulk construction. On the counter side to this, the path of construction doesn't include the path of completions typically. We underestimate the man hours required, there are few bulk opportunities, and discovery rework is something that impacts us. And this area is always highly reactive, which can then have a negative impact on construction productivity. So completions requires a detailed approach, coordinated with interfaces, understanding the SIMOps, and all done in a sequence to support effective commissioning and startup. So the opportunity here to reduce schedule is to bring the activities that typically fall in the last 30% forward. When we do this, all these milestones naturally come further forward. And what we're actually aiming to do here is add an extra phase, which is bulk completions. Irrespective of the system priority, we want to be liquidating as many completions opportunities as possible to open up downstream work fronts. When we look at a simple cascade of activities that run through the delivery cycle, one of the things that always hurts us is discovery work. So when we can bring forward all of these activities, we're naturally going to bring forward discovery work because of the inspection regime. It will reduce the back-end burden, and when we align the path of completions with the path of construction, you're going to significantly reduce schedule. In summary, AWP aligns engineering, procurement and construction and works well for bulk installation, but the completions transition through commissioning and startup can be improved. To start with the end in mind and optimize the path of construction requires a change in approach, and we need to think about systemization, test pack development and cable routing significantly earlier. The traditional approach of bulk construction to systems-based completions isn't conducive in achieving optimal results, and linking AWP and completions enablement methodologies not only improves the planning process but will improve quality of build, reduce schedules and achieve an earlier startup. Thank you very much.